Hello everyone, good afternoon. My name is Yulam Gatkos, a J2 student pursuing a Bachelor of Science in Software Engineering. Today I'm here to talk about artificial intelligence and its fundamentals. So straightforward, let's go to the introduction of artificial intelligence. So we are going to learn a comprehensive study of artificial intelligence foundations, concepts, applications, and its futures. Therefore, artificial intelligence is one of the most transformative fields in modern technology these days, actually. So, in this session, it's going to provide us a comprehensive study of artificial intelligence, its foundations, methods, applications. So, it's also going to give us a coverage of historical development of artificial intelligence, problem solving techniques, reasoning strategies, handling uncertainty, planning, and machine learning. It serves as both as learning guide and a reference source for anyone who is willing to learn, especially a student like me or like anybody else actually. So artificial intelligence, history, trends, and futures. Artificial intelligence is a field dedicated to building artifacts capable of displaying intelligence behavior. Therefore, this section introduces the origin of AI, beginning with early conceptualization, such as humanoid robots, through Alan Turing's foundational work, to the modern focus on weak and aspiration of strong AI. It actually explained the dimensions of AI, including the following: thinking versus acting. As you can see, how AI system process information versus what they actually do. Human-like versus rational, mimicking human intelligence versus achieving optimal decision making. Weak versus strong AI. So, um, as you can see, AI system differs from conventional computing by using heuristics, learning, adapting, handling uncertainty, and making implications rather than just following predetermined algorithms. As you can see, we said, so yeah, we say that system that think versus those that act, and the difference between human-like intelligence and rational decision making. So problem solving in artificial intelligence. Therefore, problem solving is at the core of AI. This section as well introduces heuristic functions which provide educated guesses that guide such processes toward efficient solution. So AI problem solving relies on defining, analyzing, representing task knowledge to choose optimal technique. As you can see, we have admissible heretics. You can see the picture. So that is in form of a maze. Actually, yeah, it is a maze. So we on the other side we have inadmissible heretics. So as they are well explained by the picture or by the pictures. Problem solving by such games graphs. Here the focus shifts to an or graphs which represent problems that can be broken. Yeah, that can be broken down into smaller tasks. The application of game theory is explained with emphasis. As you can see the graph, we have option A down, moving down upwards. Option option A or problem A, root and all problem. You can see we have sub problem B, sub problem C, option D. So Therefore, as I say, this it explain it explain with emphasis on minimax algorithm and alpha beta pruning for efficient decision making in competitive setting. We have knowledge representation and reasoning. Therefore, AI relies on representing knowledge in ways that machines can manipulate. This module covers symbolic, yeah, it covers symbolics and connectionalist approach or approaches. The physical symbolic symbol system, hypothesis, and logic-based reasoning techniques. As you can see, starts with data, which is the raw facts. Two, we have information, that is the processed processed data or processed raw facts. Of course, they are raw facts and they are being processed into information, and the information is transformed into knowledge. First order logic, uh, first order logic that is formalizing knowledge. Therefore, first order or logic provides a powerful framework for representing knowledge and reasoning. It declares semantics involve semantics. Its declarative semantics involve conceptualizing a domain and then formalizing it into a language where facts can be expressed and verified. We have conceptualization. That's A. It, this defined universe of discourse, functional basics, and relational basics. Formal language is creates a precise language to express facts about the domain. Truth and truth and susceptibility in first order logic are related to an, an interpretation, universal quantification, as you can see, means a statement is true for all variable assignment. In inference in first order logic. So inference in first order logic, as we say, yeah, as we said in the first order logic, the resolution principle is a key inference rule used to demonstrate unsatisfactority of unsatisfactority and forms the basis for automated theorem proving. It involves converting formulas to closed form and applying reason until resolution until a contradiction is found or no new clauses can be derived. So here we are saying, yeah, it provides the framework for deriving new knowledge inference using the resolution principle, and unification is explained, showing how automated theorem proving can be achieved here. Reasoning under uncertainty. So reasoning under uncertainty. Here, theorem combines probability theorem or decision theory combines probability theorem and utility theory to enable rational decision making under uncertainty. So planning in artificial intelligence involves defining action sequence to achieve specific goal. System, situation, calculus, and planning graphs are explained. We have macro decision processing are introduced as mathematical framework for decision making under uncertainty with concepts such as value function policies and Bellman equation. As you can see, we have random variables. This is our quotient. Yeah, random variables, probability, axiom, Bayesian updates, Bayesian networks. Planning and decision making. Therefore, planning involves reasoning about future events to establish action sequences to accomplish or complete specific objectives. Unlike problem solving, planning features explicit goal representation, rich state description, and complex actions schemas. So therefore, we have goals, we see explicit goal representation, we have statement, we have actions. In this way, classification planning or classical planning system like strips, assumed, deterministic, fully observable words with complete information and explicit goal situation calculus is first order logic dialects for changing words, enabling reasoning about action, results, and fluence. So, machine learning fundamentals, the core for artificial intelligence. Machine learning is a core subset of artificial intelligence. It focuses on enabling machines to learn from experience and data. It explores supervised, unsupervised, and reinforcement learning, decision trees, and dimensional, dimensionality reduction. Emerging trends such as deep learning, real-time learning, and application in diverse fields like healthcare, finance, and agriculture as also highlighted. So we can see we have supervised learning, learns from label data to predict discrete categories. We have unsupervised learning, find patterns in unlabeled data such as clustering similar incidences, yeah, like grouping or finding relationship association. Example is a customer segmentation recommendation system. We have reinforcement learning, learns from interaction with an environment, receiving rewards or penalties to maximize cumulative rewards. Examples are game playing robotics. Therefore, when we come to, in conclusion, artificial intelligence is a rapidly evolving field that continues to technology, sees influence technology, sees science and society, influence technology, science, and society. The modules covered in this session provide a strong foundation for understanding the principles, method, and application of this AI. So we have discussed more of problem solving, reasoning to planning, uncertainties management, and machine learning. So these are AI, these thing artificial intelligence present. It actually present both opportunities and challenges for the future. So as a student like me and professional, let me say practitioners, I like can use this insight to build systems that are more intelligent, adaptive, and beneficial to human being. So I would like to stop here. Thank you for watching me. Thank you for listening to me. Have a good evening.